Hello, and welcome to the 16th and final episode of Delving into Academics for Season 1. It's a podcast where various researchers from chemistry, physics, and biology are all interviewed into what they're currently researching and their lives as academics. For this episode, Professor Judy Hardy was interviewed about her research into physics education and how we can all learn and study better. So I hope this podcast helps you with exam preparation. I am here with Professor Judy Hardy. She started off in chemical physics, studying her bachelor's at Bristol University, which she graduated in 1977 from. She then went on to do a PhD, but decided to not go into academia straight away and instead went into industry for 10 years as a materials scientist. She then took time out for her family for another 10 years before coming to Edinburgh. She's the director of teaching. She leads Physics Education Research Group and teaches a couple courses, including modern physics and computer simulation. Thank you for coming on the podcast.
It's my pleasure.
So tell us about your work. Tell us if you're doing any research projects or like day-to-day life.
Okay, well, thanks very much. So where do I start? Well, I guess being director of teaching, a lot of my day-to-day life is actually around teaching, not just teaching courses, although of course I do teach, but also around keeping the wheels running, I suppose, on teaching in the school. But I think you're particularly interested in the sort of work that we're doing in our physics education research group.
Yeah.
So let me tell you a little bit about that. We're quite a small group in the department, but we have been going for quite a long time, and we work on a variety of things. I suppose my fundamental interest is well, there are a variety of things there as well, but my fundamental interest, I suppose, is trying to understand how people learn about physics, how people understand physics concepts, what we can do to help people understand and help with that learning. It's one of the things that sets, say, an education research group in physics or in chemistry or in maths or in whatever subject apart from the School of Education here, where people do a lot of research in education, but they're looking at it in a somewhat broader and different context. We're much more interested in our discipline and physics and what is it that causes difficulties here, what can we do to help. So much more focused on the subject, and physics, as I think, has got a, it's not known generally as necessarily an easy degree. I think some of the concepts in physics and some of the subjects that we study take a long time to understand. They're not straightforward, but I find that fascinating. Some of the work that's been going on, sort of growing out of physics education research, not just me by any means, but by other people, are things which I think pretty much all students here will have encountered at some point, which is the flipped classroom idea and the use of clickers in lectures to try and do conceptual questions to see how you're understanding stuff and to try and get yourself engaged a little bit more in a lecture. So we've done quite a lot of work looking at that and looking at what sort of impact these types of techniques have. I've also done some work looking at trying to understand how we can spread these sorts of ideas out, so to get more people, this is much more on the staff side than the student side actually, but we can get more people to try and use these where appropriate, where would they work well. We've done some work looking at what we call diagnostic testing. It sounds a bit grim, but it's not really. So this is testing to try and understand how people understand concepts. So it's not the same as exams, it's not for assessment, it's just to see how people understanding physics. And we can use that not not because we're in that context we necessarily want to know how any one individual student does, but we want to know, does this method work better than that method? How are we going to assess that? So we can ask people questions and so on about that. A whole variety of things really, but a fundamental to all these are physics and I guess beyond that science in a more general sense, because many of these things apply, but particularly physics, and how we can help improve learning is the basics. So that's a quick sort of slightly random survey of the types of things that we're doing in the group.
Yeah, it sounds awesome. Yeah.
One more thing actually, recently we've been looking at something which I know is quite current for students, which is use of lecture capture.
Okay. Yeah.
And how is it being used, what are students finding useful with it, what lessons can we learn from it, in terms of something that I think would be very helpful, which is, can we give advice on the best way to use these types of resources? How do they fit with the other types of resources that students have to work with? So a whole range of things.
Yeah, no, that sounds brilliant. And to pick from one of your points, the flipped classroom idea, what is this idea and how would the professor go about it?
Oh, flipped classroom. Right. So, first disclaimer. Flipped classroom is an idea that actually came out of the school sector. It's not something that we have invented, if you like. But so the idea of flipped classroom is something where students will prepare the material before they come to lecture. So there are several stages to it. So you will perhaps look through lecture notes, or in the original incarnation actually would be watching videos, but we don't do that. So you read through lecture notes, you answer perhaps a quiz before the lecture. I think you may remember this from first year. Yeah. You answer a quiz on the topics and material that you've been reading. The intention of that is not that students should have perfect understanding of that material, but that you should, if you like, you start to grapple with it, and also have some idea of what it is that you don't understand, what it is that you find difficult. We as staff might think we know that. Sometimes we're right, sometimes we're surprised. Things that we think would be obvious are not. Things that we think would be tricky are not always. So to try and get some understanding of that. And if you cast your mind back, you might remember one of the questions on those quizzes is often, tell me something you don't understand. And then the idea then is in the lecture. The lecture then will focus on the parts of that material that students have found difficult. And it's focused around the use of top hat or clicker questions. So asking people to think about these things and to give feedback to the lecturer, if you like, on how they're understanding. And so the lectures are focused very much around that. And then after the lecture, then there are workshop questions and so on and to work on. So it's called flipped because it's, if you think of a traditional lecture, you'll often go along to the lecture, you'll listen to the lecture, you'll write some notes, you'll maybe understand it, you'll maybe not, and you'll go away and then try and figure out, improve your understanding of it. Yeah. This is flipping it up front. So you do that before the lecture, and then in the lecture you can focus on the parts that you don't understand, and the lecturer can do that. Within flipped classroom, the thing that goes with it often is something called peer instruction inside a lecture, which is very much based around the use of the top hat or clicker questions. And the idea here is that you are asked to answer a question and you vote on it anonymously and you give your answer. And then you're asked to turn to your neighbour and discuss it. Again, does this... Yeah, ring any bells? You discuss it with your neighbour and then you re-vote. And often, not always, but often what will happen is that in that discussion you will improve and help your own understanding. And so you will, as a group, you will move towards an understanding of the subject. And that also helps in terms of it actually, I don't like to use the word force, it's not a nice word to use, but I can't immediately think of the right word. But it does, it means that as students you're then directly engaged with the subject that you're learning. It's very easy to be, when you in a passive lecture, it tends to be rather passive. You maybe think you understand, but when you think about it later you don't, or maybe you just think I'm lost here and it just washes over you. But this, you need to be engaged and you need to think about it. And so that's the idea of using peer instruction. You may ask, well, why do we make you vote as individuals before? Part of that actually is for staff to get an idea of how are people doing. Part of it also is actually that act of voting forces you to commit to something.
Okay.
Yeah, here's a set of options, right? I need to choose one of these. And so it does make you commit to something, it makes you think about it. So there's many reasons for doing this sort of stuff. So that's what flipped classroom is. You turn things around to focus the lecture on this more active discussion over what people are having problems with than on the transmission of the material. It tends to work and be used most in the first year classes, in the big first year classes, because this is where the classes are so big, it's quite difficult to get a conversation going.
Yeah.
They're big, right? And if you're there in a class with 300 students, it's not so easy to get more discussion going. In the later years classes, it tends not to be needed because the classes are smaller and students, you're starting to understand your own approaches to learning and so on. Although we do use the clicker questions, the top-up questions, of course, in later years as well. So that's a little bit about flipped classroom.
Yeah.
And there is lots of evidence, actually, across the world, that these types of approaches lead to better understanding. Lots of evidence.
Yeah, that's awesome. Yeah, I know quite a few of my friends are like, yeah, this actually really helps me, and I like this type of lecture style because I kind of come already knowing a bit about the topic, and then to have the harder topics or the topics that maybe people didn't understand so well, to then have those discussed in lectures kind of helps with understanding. Yes,
exactly. Would it work in 4th year, 5th year? We don't know. There's not much work being done there, actually. I personally think on a research side, I think it would be really interesting. But we haven't done that yet.
Yeah. So how then what methods do you use to find out if these types of methods of learning are working? Do you interview students or do you do the methods in like lectures and classes and stuff and see from there the results that are coming forth in like exam results or something?
These things don't always come up in exam results, actually. What we tend to look at are, and this is where we bring in what I've just mentioned before, which was the idea of these diagnostic tests. So a diagnostic test we would give students the test before they do the material and then after they've done the material as well, and look to see what changes and how students hopefully have improved their understanding. So the tests are designed to test for conceptual difficulties in particular. So again, you may remember doing this in first year where you had a test beginning and the end of Physics 1A. Yeah. That's what that is. And we can look then to see how the class has improved on those particular topics. There are a whole range of these tests that are available, not within the university, they've been developed elsewhere. What this means is that we can use them for looking at how we're doing and perhaps then to compare that with what's happened in the literature with other things that people have tried. Because this sort of research is quite complicated in the fact that people in studying is quite messy. It's not like a lab. You can't set everything up to be this sort of ideal experimental condition. And so to have these tests that are used in different universities, we can then compare, well, how are we doing? What are we doing that's working? What are they doing that's working? What can we learn from each other? So that is one method. We can talk to students, we do that sometimes, or we can survey students, we do that sometimes. And so we can look at a whole variety of things. And we can also, as I say, look at what's been done elsewhere and then see what we can use and apply here and work it to apply within our own context. Yeah, so that's typically the way we do it. So we use a whole range of different methods, some what we'd call quantitative, so getting test data or getting survey data, some what we call qualitative, talking to students, assessing student views on these things. We also do that as well.
To then also take it back again to what you were saying at the beginning with lecture captures and stuff. What kind of work are you doing surrounding them, and what are the results that you've been finding so far?
So I think this is ongoing work. The lecture capture has really, well, across courses it's really not been in place for very long. It's quite new here. I know in some courses it's been going a long time. But what we were interested in there, where we're working on a project actually with the School of Maths, looking at how lecture capture was used in first year courses, but I think it applies across other courses. And what we were interested in is what is the way it was being used, what students were doing with it, how much it was being used, and so on. And as I say, the research is a little bit an early stage, but one of the things that came out quite clearly, actually, particularly from talking to students, is it perhaps sounds obvious, but it wasn't necessarily. Lecture capture is one thing that's available among a whole range of things that's available. And so it's used along with notes, along with maybe slides, along with the actual lecture. It's used along with resources that students might find online and so on. And I think we need to do more work to understand how does it all fit together? What makes recordings of lectures useful in a way that, say, reading notes doesn't? What makes students perhaps want to revisit this? One thing that is clear is that, and this is a generalisation, I realise that, often people will look for the bit they want to look for. It's not a matter of sitting down and doing a sort of box set revisit of 20 lectures in a binge weekend. That's not seems to be what people are doing. So perhaps picking out the bits that people need. But how does it all fit together? And that's one thing we don't really have. I don't have an answer for that, actually, and I don't know if there is a clear-cut answer. But I think that's something that's quite important, because to think of any one thing in isolation probably doesn't make too much sense. Because when you're studying, and I feel I'm speaking on other people's behalf here, and I hope I'm not trying to do that, but from what we can tell from talking to students, of course, when you're studying, it's not in isolation. It's these many things. Yeah. So what is it that makes these different things useful? And from that, we can then think, well, okay, if one particular thing is useful, what can we do to sort of maximise that, and what can we advise students in the way that they use maybe lecture recordings along with notes, or along with going through problem sheets, or along with whatever else it is that people might be doing. So that's a really woolly answer, and I apologise for that, but actually it's because I think we need to do more work here. And various messages came through from this, but I think the key thing to me is that A, it's complicated, and B, it shouldn't be looked at in isolation, because it doesn't exist in isolation. Does that sort of resonate at all?
Yeah, absolutely. I know from my own sort of studying, I will get so bored if I just have one type of study. I need several different bits and pieces on the go, like questions and then notes and then know, videos on like YouTube or the lecture recordings. So yeah, for me.
But equally, you don't want perhaps to be flipping too often. Because that leads to this fragmentation, which isn't always helpful for progressing in your study. So,
exactly.
Yes. So we will see with lecture capture. I think it's really interesting, and I absolutely see that it has value. And of course there are situations where it has a different type of value. If people have not been able to attend lectures for whatever reason, then it has a different type of value. We absolutely understand that. My particular interest in the terms of research is for students, in the more sort of who have been attending lectures and who have been going to workshops and so on, who are able to, in that situation, how does this all fit together? So I think it's interesting stuff. I think watch this space actually is the answer there, because we're not there yet, but we're getting there.
And that actually leads quite nicely onto another question I have. Where do you see physics education progressing in the future? Because as you say, lecture capture is up and coming, so to speak, and say 10-20 years beforehand kind of didn't have that, and like with the internet as well coming through. So where do you see it moving forward?
Oh, that's a really interesting question. So, where do we start with this question? There are a whole range of things, actually. There are some quite sort of pragmatic things here. There are questions still around how do we work on improving this interaction, particularly with big classes. There are bigger questions around, if you look in the literature, you will see literature on what's the future of lectures, particularly with the use of online resources and so on. There are many questions around education in its broad sense in this context. Within physics, though, I think in terms of the future, I think there will always be questions about student understanding. Actually, well, understanding. Let's understanding. I think that there will always be work to be done in terms of helping to improve the way that people understand material, helping to improve the way that we can design courses, design assessments, and so on to help with that. So the future, in a sense, looks a little bit like the past, which sounds a bit dull, but I think that will continue. I mean, I haven't talked much about assessment. I mean, that is another area that I think is really quite interesting. We haven't done a lot of work in that area, but it's maybe something we should look at. I don't know. The School of Mathematics, for example, there's a lot of work in online assessment, which we haven't done. I think there's some interesting things we could think about there. So a whole variety of things. What are the big questions? The big questions, I think, will be, it's interesting. Depends on your focus. I think the big questions are actually around how do we move as much as and as well as we can to this more interactive style. And so to get the time that we and students have together to be the most effective that it can be. That to me is the key. We have limited time. How do we make this work as well as we can? That would be, if I could answer that question, it would be fantastic. If I had I don't think there is a single answer actually, because I think it depends on what it is you're doing.
Yeah.
But I think that would be great. But then, I'm not sure there's necessarily. It's not going to be a numerical answer to that particular problem. So whether we'll ever get there, I don't know. That would be where I'd like to get to.
Thank you. It's quite a nice end goal.
It's a great end goal, isn't it? Because I personally think there will always be room for the direct face-to-face contact. I think that's quite important. Certainly as teachers, we think it's important. So we'll see.
Yeah, absolutely. Because I have found, personally, I think lectures are great, and I love attending them, and I love attending the workshops to ask about questions that I've found difficult or can't do or something. But I know other people don't find them as useful.
Absolutely.
So it's a very subjective thing to be studying and to look at. So what do you think about the subjectivity of this research? Is it a pro or a con to doing this type of research?
So you've actually raised an interesting question there about different people approach studying in different ways, and of course that's true, and that will always be true and should be true. One of the things I would actually like to understand, particularly you mentioned people who perhaps think that the time spent in lectures or in workshops is not the best use of their time. I would really like to understand what it is that, and well, let me be quite honest, I would like to understand the reasons for that, because is there something that we could and should be doing differently that would help, that would make things better for those students, either in terms of what we do in contact time or in terms of other things that we should be doing. And let me be quite honest, one of the difficulties we have as research is actually getting at those students. But I think that's an interesting question, and I think it's a very open question that we don't really know the answers to. I mean, we do tend to supply quite detailed notes and so on. Is that sufficient? I don't know. But I would like to know the answer to that. So students who would like to come and talk to me about that, I would be really, really keen to talk to them about it. In terms of the subjectivity, I think what you're talking about there in terms of subjectivity is subjectivity of the research that we do. There are a variety of methods you can use actually to try and overcome that. So what's what we would call mixed methods approach. We would use mixtures of looking at, say, test data, looking at surveys, talking to students, and you use these different techniques to try and ensure that the conclusions you reach are based on, they're consistent with all these different viewpoints. It's quite common in the educational field to use this because it's the nature of the work. It's in this sense a little bit, it's complicated and it's messy. But there are these ways of called triangulating the data, so we can look at these different approaches and say, yeah, there are consistent things coming through here. In lecture capture, generally speaking, as I say, students don't sit and look at a box set of 20. They'll go to the bit that they want and they'll look at this. And actually that's consistent when we look at perhaps the statistical data on what's being used in terms of length of time spent on recording. So, we can try and get consistent answers from doing that sort of research.
Yeah, great answer.
Yeah. We've also been doing some work, actually, I forgot to mention this one, on use of clicker questions in flipped classroom, what actually goes on. So this is where we've actually been using lecture recordings, with lecturers' permission I should say, to look at what staff have been doing in lectures. And that's been really interesting. And so even a technique that is the same is used in different ways by different people, which probably isn't too surprising, but it's interesting to understand this and figure out, well, what is this telling us about what's effective and what works. So lots of stuff we're doing there.
Great variety.
Yeah. Many of which are student projects, actually. So we do senior honours and integrated masters projects on these areas. So lots of student projects here.
Yeah, and so another of my questions is, what method in all the research you've done over the years, what method have you really seen is the most effective in learning and physics education? Mm-hmm. Not necessarily what's your favourite method.
No, I understand.
Yeah,
objectively, the flipped classroom is probably the most effective method, in that we have data, there is a lot of data in the literature which shows that method improves student understanding. However, that method is used by us and most of the people who use it for a particular set of students who are first year students. And so I would not want to generalise that to the later years because the work has not been done there. More broadly, we know from work we have done, and again from a huge amount in the literature, that techniques which, and this is in terms of what I would call contact time teaching, because that's what we can influence directly, techniques that lead to more student interaction, more student what we call engagement, are more effective. That's the broader question. Hence use of things such as top-hat questions, even if you're not doing flipped classroom, to improve that level of engagement. There is a lot of work that shows that is effective. Now, will there be some individuals who don't feel that that's for them? Yes, that's true. In this sense, it's a statistical. Of course, students are individuals, we know that. But what we have to do is to look for what's most effective for the majority of people.
Yeah.
It doesn't mean we're not interested in ignore the minority, but that's a different question. So please don't take what I say as this applies equally to everybody. It's not intended to that, and I would never consider students to be this amorphous blob. That's not the case. But we need to look at what's most effective for the most students, the majority. So that's my answer.
Yeah, and that's a great answer. And I mean, you're right. It isn't one big student body. There would be individuals, but it is good to work for the majority rather than maybe the minority sometimes. Yes.
And similarly, as teachers, we are also different, and we have our. And I think I've never asked this question. I probably should, but I would think it would be actually quite dull if everybody used exactly the same approach in every lecture. I think that would be pretty dull and wouldn't necessarily work, because as staff, different people have different approaches and they can work well within their context. Yeah. So, in some courses the use of slides might be appropriate, but in many courses the use of Blackboard is appropriate. And, you have to fit it to your own context. So there is not necessarily a single correct answer here. It's what makes it so interesting, actually. From a research perspective, it's what makes it so interesting.
Yeah, I think personally I'd be a bit... Well, I'd find it very interesting, but like never getting to a complete final answer. I'm very numerical that way. I mean, a definitive answer. I'm like, yes, this is right.
Yeah, absolutely. So, well, of course, in research, that's an interesting question. Even in physics, if you don't know what the answer is.
Yeah.
But you're right. It's something that often with students who will work on a project with us, it does require a different mindset, actually. Although we do statistical testing, and we do have there is numerical stuff in here, so it is numerical. But yeah, you in a sense there isn't a definite endpoint.
Yeah. I mean, is that your most favourite thing about doing this kind of research then, or like what inspires you or like intrigues you so much about physics education research?
Well, it does sound quite trite, but it is true. Actually, what I am just deeply interested in how people learn, and how people learn this sometimes quite complex, quite sophisticated, quite non-intuitive topics that have taken a long time and many inspirational people to develop. Actually, that is what inspires me. What really inspires me is when we see the impact and you see the light bulbs happening. That is actually what really inspires me. But I think that process of getting there is really interesting. But that's a very personal thing. That's what me. But I think actually everybody who is working in this area, this is linked intrinsically to teaching. And how can we do that in the most effective way that we can to help students? And by teaching, I mean from that learning. But it's that actually is what motivates everybody really in this area.
Yeah. Awesome. And like, do you do much work with lecturers in developing their teaching, or maybe seeing the ways that different lecturers teach?
Yeah. So yes, I mean we have a scheme in the school actually called peer observation of teaching, where people will observe each other's lectures. You may have come across that occasionally where people are sitting in on each other's lectures. So we do have mechanisms for doing that. And we also have ways that we can share the types of approaches that we use, and we can look at what was working and what would perhaps be appropriate to try in a different course. And I think in some ways, having done this work in physics puts you at an advantage, because people say, oh, well, if this works in physics as opposed to in, no offence to art historians, history of art, then that might be right for me. So it's perhaps more easily transferable. And yes, I mean we do have a variety of ways, just communicating with people really to try and do that, or we'll have all sorts of things that we can do.
Yeah, that's awesome. And have you seen lecturers really engage in this type of research method? So maybe like the flipped lecture idea, like lecturers really like are like, yes, I'll try this out. That can then feed back into your research. Or
yes, that does happen, and it does feed back in that people will generally want to evaluate things that they've tried to see if to see what impact these have had. As I say, the particular one, that flipped one, really has tended to well, actually no, that's not true. We're using it a little bit in second year now as well. So it is in that sense spreading. Some people, are people willing to try? Yes, some people feel that actually other approaches are better for them, and that's fine.
Yeah.
I would not ever want to mandate what people must do, but I don't think that's the right way to do it. But yes, I mean there is always an interest and a willingness to find out what's happening, what people are doing, what people can learn from that in terms of their own teaching.
And in terms of being an undergraduate and a student and going through the process of learning these difficult concepts, what kind of advice do you have for them if they're looking at doing research in the future or just currently in their studies?
Well, I suppose one piece of advice would be don't panic. And what I mean by that is I genuinely think for many good students, some of this material is hard and it takes time and it takes application, and that's okay. And that's one of the things I think that makes it so interesting and fascinating and so satisfying, and that it can take time, and that the steady application is what's needed. That would be my advice, and not to panic if you feel that I've read this and where am I going with this? That's normal, and it does come. That, I suppose, is my sort of one piece of advice I would give. And really, there is a lot of work that says what we call space practice. So just keep on at things, keep it ticking over, keep coming back to it, and you'll get there, actually. That all sounds terribly negative, doesn't it? And it's not meant like that. But I think that's often what's needed, just that sort of steady approach.
Yeah.
Don't, the obvious things, really. Don't leave everything to the last minute, because that's... Well, actually, it's not going to work in many ways. It's not going to work because it just requires getting everything into your brain and straight out again, and there's a lot of stuff. But actually, to develop this deeper understanding does take time.
Yeah.
I don't think there's, for most people, there's not a way around that, which is why I think just trying to keep on top of things and accept that it was going to take a little bit of time may be quite helpful, maybe. And of course, use all the materials that are available to you. So use all the resources, and by which I mean everything from speaking to staff, going to lectures, using your notes, everything in a way that suits you. But use them, of course.
Yeah, that's great advice, and definitely something to keep
I don't know, does that resonate with you?
A little bit, because I can be a bit impatient, and I would just want to understand it now. I would want to get to grips with it right then and there.
And does that work? Sometimes it does, probably.
Sometimes I do need, I find especially with revising for exams, when I'm going back over all the stuff, I didn't quite actually get that concept as much as I thought I did, and then it kind of takes time. But I also find it's kind of difficult when you have an exam at the end.
Yeah.
You're like, oh, I need to understand it for then.
Absolutely.
It's sometimes difficult to grasp such a deeper understanding with a deadline attached to it. Yeah.
No, I understand that. It puts a different focus on it, and that, I do appreciate that. In my ideal world, in my ideal education research role, I wouldn't have those. But on the other hand, if we didn't have any sort of continual assessment, I think that wouldn't be so popular, because I think students like to know how they're doing as they go along.
Yeah.
And it can help motivate people to stay on top of things. So it's trying to get that balance right, actually. And that's always an interesting question. And the other thing, actually, I know not all students, but a lot of students actually find it useful to help and talk to each other. Teaching is a great way of testing your own understanding, actually. And so not all students, I know some students do prefer to work on their own, but to discuss things with other students can be quite helpful, because you're all at a similar level, really, and that can be useful. Yes.
What is this ideal education research world? What would you kind of use instead of exams?
I see what you mean.
Yeah.
So in my ideal world, right? In my ideal world, I would be interested in what students know at the end, actually, because different people progress at different rates, and in a sense, that is much more to do with developing your understanding than being what we call summative assessment, so assessment for marks. Yeah. So in my ideal world, these assessments along the way would just be for understanding, because like you say yourself, learning to a deadline, and that deadline has a mark, and that mark's going to count, puts a very different focus on things.
Yeah.
And actually, this is my ideal world, it would be okay to say, look, I've only completed a quarter of this because I just don't understand this. And that would actually be really helpful, because then you can have the discussion about, well, okay, what is it that you don't understand, and let's talk about that, and it's fine because this is formative, it's not going to count. But I equally know that that isn't necessarily so helpful for students, because you perhaps want that reassurance that not everything is resting on the end. because then that puts really high stakes on the end assessment, whether it's an exam or whatever it is.
Yeah.
And that's problematic because it depends on how things have gone then at that time.
Yeah.
So that's why I say from an education research perspective. But of course, then you have this difficulty at the end. So don't get me wrong, don't worry, I'm not advocating that, and I wouldn't. But I would like to find a way to help reduce that need to spend a lot of time, perhaps sometimes too much time, on continually assessed pieces of work towards a mark.
Mm-hmm.
But I don't know what that way is, actually. I don't know.
Yeah.
So, yeah.
It is a problematic topic. Even with students discussing it, they're like, oh, I wish I didn't have this exam, but what would there be?
What would you be? Well, none of us like exams. I know exams are in everyone's mind at the moment because they're either on or they've just finished them. But nobody likes exams, right? Nobody likes exams. Yeah. We don't actually have a better way of assessing that now, though.
Yeah, exactly.
So it's what I would call the least worst.
Yeah, that's a perfect way to put exams.
Yep.
Yeah. And yeah, that's brilliant. Thank you. And so for my very last question of the episode, do you have an inspirational book/article that you want to share with us?
Oh my word. Do I have a... Well, this is somewhat embarrassing because I don't think I do actually. This is a field where we don't have the seminal paper. We don't have the seminal textbook. So right immediately, what can I share? No, actually, right, I'm going to think of one thing. This is not physics education, and that will have gone off the page. Here's one I think is really good. This is a book, and it's called How Learning Works, 7 Research-Based Principles for Smart Teaching by Ambrose and other people. It's actually aimed at educators rather than at students. It's not physics education research, it's education. But it is a book that is based firmly on education research principles, so what I would call research-informed principles, where we've seen evidence that these things work, but is written in such a way that it's aimed at people who teach, many of whom are not education researchers. They're researchers in many other fields, but want to do the best they can in teaching. And it's written in such a way that it really, I think, has got many proposals and so on that really people can use in their practice, but also helps explain why these work and what the underlying research is that makes these effective. And I think that's a great combination for people, because there are many people who, as I say, they're not doing the education research, but they want to use things that work and they want to understand why. And I think this book is a very good book for that. And so that's a book that I think can be quite... I read that book and was quite inspired, and I think many people who read it are.
Awesome. Yeah, thank you. And thank you so much for taking the time to be on this podcast and for sharing your research with us.
It's a pleasure. It was lovely to talk to you. Thank you.
So thank you for listening to this week's episode of Delving into Academics, and I hope you found it interesting. Please like, review, comment and subscribe wherever you're listening to this. And if you want to find out more about the researcher, I will have their university website page linked in the description. See you in 2 weeks for another episode.